Hello everyone. In this video, we are going to talk about stacks in C++ STL. Stacks is basically a stack data type that follows LIFO. LIFO means last in, first out. That is, the element that is inserted last will be first removed. So stack in C++ STL just mimics the functionality of actual stack. Stack is very useful while solving many problems like parsing, expression conversion, bracket matching that are very hard to solve by any other methods. Stacks make our tasks very easier for solving that problem. That problem are often asked in the interview rounds, so stacks will be very useful for solving them. We'll be seeing various operations that stacks follow, like top, which gives the top element, pop, which removes the top element, push, which puts a element to the stack, size, which gives the size of a stack element. So before moving further, we are going to look at to the internal structure of a stack. How does a stack look like? So basically this is how a stacks look like. So there will always a top pointer which will be pointing to the top element of the stack. So if you want to access this 3, you need to remove this 9 first. You can't access it directly. So many operations like push, pop and top happens in constant time because we just need to access the top element. But like traversal in stack happens in big of n time because we need to remove this element, then we need to access this element. If you want to access this element, so we need to remove all the elements before accessing this element. So traversal takes much time, but operations like push, pop and top and size takes constant time. So you can think stack as an example of this book. It is a stack of book where there are many real life examples of stack, like stack of coins and many others. So let us look at how this push and pop operation work out. So let us consider one element we are going to insert to this stack. So we perform push operation. This is the operation that stack supports, push. So it's gonna push one to the stack. We need to pass a parameter in the push function here that will be inserted in the stack. So let us insert one more element, that is 4. Then this top pointer will be removed from here, and this top pointer now will be pointing to the top element. Again, if you push one more element, then again this top pointer will be removed and this top pointer will be pointing to the top element. Similarly, if you insert one more element, this top pointer will be removed and this top pointer will be again pointing to this element. This all top pointers are same, they just change their address pointing to the top element. So let us look at to the pop function of stack. So for that, let us consider the same stack that we are having now, and this top is pointing to this 9 as of now, as 9 is in the top. So if you perform a pop operation, this 9 will be removed and this pointer will be now pointing to this top element, that is 3. Similarly, if you do pop again, it will remove 3 and again this pointer will be pointing to the top element. Similarly, you can remove all the elements in the stack. So this pop doesn't take any parameter like push and removes the top element. There is one more function that is known as top. So this top always return the top element that is stack having. So if we do top here, it will return us an integer value 4. Stack can contain other data types as well. As it is a container, it is a generic container, we can always put on character, string, integer, float value in the stack. So just to note, what happens if we keep on pushing the element? Does it have some limit? Yes, system puts a limit on the stack size. Often we get a stack depth reached or recursion limit reached, something like this error. So system always put this size limit on this stack. So if you keep on inserting and pushing value on the stack, it will reach a certain point where the system will throw you an stack overflow error. Stack overflow generally means that the size of the stack is full, you can't insert any more element into the stack. what happens if we keep on popping the element, and if there is no element in stack and we pop element. So for that, system will throw an error known as stack underflow. That means the stack is empty, you can't delete element from the stack. So basically we have seen many functions: pop, push, top, and we'll be seeing size, and this two uh, majorly known errors, that is exceptions in stack, that is stack underflow and stack overflow. So let us look at to the implementation of stack in STL. For that, I have declared a stack.cpp file where we'll be writing the code. The first thing we do is include the header file. So we'll be including the header file for stack, which is stack. So this is the header file for stack. Okay, fine. So next thing we are gonna look how to declare a stack. So there are many methods for declaring stack. We'll be looking to one of them, and the famous one. So as we know from other containers, we need to write the name of the container with these brackets and name of the container. So this stack is a keyword which declares the stack container, and this is the name of our container. So here we need to pass on the value that our stack gonna contain. So we'll be for simplicity considering it as int. So this stack will contain integer values. So the first function we are gonna see is push. So this push takes a element as a parameter and insert that element to the stack. So we just need to do s dot push and pass on the element. Let us pass on 1. So now stack is containing one element, that is 1. Let us push one more element. So as we have talked that push puts the element at the top. So now the 1 is below 2 and this 2 is pointed by the top. So basically the top element is this 2. So let us check that what is the top element. So for that we need to do s dot top. So it will be returning us the top element, that is 2. Let us check, compile and check. So as you can see, it returns us 2. So this s dot top returns the top element. So if you insert one more value to this stack, so that will become the top element of the stack, and if you do s dot top, it will return us this 3 as we have inserted this at last. So basically it is following LIFO, last in first out. So if we do s dot pop now, so as you have seen that it's follow LIFO, so last in first out. So last was 3, so the first removal of the element will be followed as 3, so it will remove 3. S dot pop will remove 3. So let us check the top element after it. S dot top again, this is after removal, sorry, removal. Okay, let us compile and check. So as you can see, it's outputting 3 and 2. So this 3 is from this cout and this 2 is this from this cout. So as we have seen, 3 was last inserted, so it removed 3. This pop element removes 3. So there are other functions as well that will return the size of the stack. So that is known as size, s dot size. So this s dot size will give you the size of the stack. So basically we have inserted 3 elements, then we have removed 1 element, so the size of the stack should be 2. Let us compile and check. As you can see, it is returning 2. Let us comment this cout statement we had previously. Let us compile and check. As you can see, it is returning 2. So we have inserted 3 elements, we have removed 1 element, 2 elements remaining, so it's returning 2. So this size returns the size of the stack as an integer. So there is one more function that we are going to see is known as empty. So Empty returns a boolean value that tells that stack is empty or not. If it returns true, the stack is empty. If it returns false, the stack is not empty. So we are going to tackle this using if statement. So f dot s dot empty. So if this return true, this will be executed. That means stack is empty. And if it is false, stack is not empty. So let us write our cout statement. Stack is not empty. Fine. We'll copy this and paste it out here. Stack is empty. So let us compile and check. So it's return stack is not empty as of now. As you can see, it's returning stack is not empty as the size of the stack is 2. So let us do one thing. Let us comment this out and comment this out as well. So let us compile and check. As you can see, stack size is 0 and it's returning stack is empty. So this returns a boolean value. If this is true, stack is empty. If this is false, stack is not empty. So before going to pop any element, it's always better to check that stack is empty or not. So for avoiding the stack underflow error that we looked into previously. So we looked into various function of stack: pop, push, top, size, empty. So basically this all operation happens in the constant time. That's why stack plays an important role in the world of computer programming and interview rounds as well. If you need to traverse the stack, again the time complexity goes to big O of n, that is linear time. But if you want to access just the top element or push an element or pop an element, it just take a constant time. So many problems like find next greater element or find next smaller element that are oftenly asked in the interview can be solved using stacks very easily.